Hi, we are from Group 6. The presentation topic of our group is formation of acrylamide. Have you heard about acrylamide before? Do you know what is acrylamide? Let's get some knowledge on acrylamide from this video. Acrylamide is a chemical compound naturally formed in starchy foods during high temperature cooking process at a temperature above 120 degrees Celsius. For example, bread, French fries, coffee, cookies, and potato chips are the major food sources of acrylamide. Acrylamide is formed during baking, grilling, frying, and roasting. There are some physical and chemical properties of acrylamide. Acrylamide appears as a white, or colorless, odorless, crystalline solid. Acrylamide is soluble in some solvents such as water, alcohol, acetone, and chloroform. In contrast, it is insoluble in benzene and heptanes. The melting point and boiling point of acrylamide is 84.5 degrees Celsius and 125 degrees Celsius respectively. It is stable at room temperature, but it can decompose under UV light, or at its melting point. This is the chemical structure of acrylamide. Acrylamide is also widely used in industrial application. Acrylamide is used as a monomer for the synthesis of polyacrylamide, which is used for water purification, production of contact lens, and making dye. Acrylamide can be also used for production of paper, formulation of grouting agent, and plastic synthesis. However, acrylamide is classified as Group 2 carcinogen by the International Agency for Research on Cancer. Studies found that high levels of acrylamide exposure has toxic and carcinogenic effects on human. Do you know how does acrylamide is formed? There are few pathways to form acrylamide. One of them is the formation of acrylamide via the Maillard reaction. Basically, Maillard reaction is a non-enzymatic reaction that gives browning effect. When condensation reaction between amino group and reducing sugars happens, browning effect occurs. This provides the food color, aromatic scent and flavor to make the food more appealing. Acrylamide is often formed during high temperature cooking process such as frying, roasting and baking with temperature 120 degrees Celsius or above. It also formed especially in high starch content or plant-based food like potato. The high temperature makes the amino acid in food to form a new compound with the carbonyl group. Let me explain the formation of acrylamide through Maillard reaction to you step by step. Here's the procedures from asparagine, which is an amino acid, to acrylamide at a glance. Let's look at the first step. The R amino group of asparagine react with carbonyl group, lead to the formation of Schiff base. This is the first step of formation acrylamide. Then, with the heat treatment, the Schiff base decarboxylates with the facilitation of the delocalization of negative charges. The decarboxylated Schiff intermediates are formed. This is the second step. Lastly, the decarboxylated Schiff intermediate will be hydrolyzed with the presence of heat to form 3-aminopropionamide. The 3-aminopropionamide will then be further degraded via the elimination of ammonia to form acrylamide. Alternatively, decomposition of the decarboxylated Schiff intermediate could also occur to form acrylamide via the elimination of amine. That's all for the process of acrylamide formation. Once again, this is the overall process at a glance. Acrylamide can be formed through tobacco smoke too. Researchers conclude that acrylamide could be the human carcinogen monomer that is formed in heated starchy food as a result of Maillard, as mentioned earlier. Unlike the formation of acrylamide in food preparation that happens under a long time heating period, tobacco processing happens at lower temperature. The formation of acrylamide from tobacco smoke can be explained through the production of cigarette tobacco. The production of cigarette tobacco can be divided into 3 stages. First, the cultivation of tobacco. Second, the curing and selection of cured tobacco. And finally the post-curing stage. In the first stage of tobacco processing, tobacco leaves are harvested. Levels of acrylamide in tobacco are failed to detect as uncooked and unheated plant material contain no measurable levels of acrylamide. Proceed to cure and selection of cured tobaccos. The leaves are dried using heated air. The process involves the wilting, yellowing, and drying process, are carried out under temperature 30 ± 3 degrees Celsius with temperatures under 38 degrees Celsius and usually takes a period of 4 to 8 weeks. The yellowing process is typically carried out at 35 degrees Celsius for 2 days. After the yellowing process, the temperature is raised the next 6 days to a maximum of 72 degrees Celsius for the drying stage. After the curing process of wilting, yellowing, and drying process for almost 8 weeks, the level of acrylamide in cured tobaccos are tested to be relatively higher than measured in uncured tobaccos. Finally, at the post-curing stage, which involves the storage for cigarette production, the tobacco intended for cigarette production will be stored at an ambient temperature of 15 degrees Celsius to 21 degrees Celsius. At the post-storage stage, the tobaccos are moistened, blended and are cut to targeted size. During the operation, the temperature of tobacco could literally reach up to 70 to 80 degrees Celsius for some minutes. Researchers stated that these could have contributed to the acrylamide contents in cigarettes. However, an article at Britain American Tobacco mentioned that the exposure to acrylamide through SDP use is smaller than the exposure from cigarette smoking or from the diet. Acrylamide levels in SDP were significantly and positively correlated with pH, but not with levels of either reducing sugars or ammonia nitrogen. As a simple conclusion, acrylamide generation in tobacco generally appears to occur at lower temperatures, but longer time scales than found with food production. Let us see how does the acrylamide formed from lipids. Acrylamide can be formed when dietary oils or animal fats are being heated with the amino acids at elevated temperatures. In the production of acrylamide by heat treatment with amino acids, there are 3 carbon unit compounds such as acrylic acid and acrolein, which form from lipids through oxidation. Acrolein is formed by the transformation of lipids and degradation of amino acids. Conversion of acrolein into acrylamide is such a reaction between ammonia liberated from the amino acids. The transformation of lipids is one of the processes that formed acrylamide due to occurrence of acrolein from the lipids. Acrylamide can be detected in the heat treatment with the presence of amino acids and hence 3 carbon unit compounds such as acrylic acid and acrolein is formed. Acrolein is a 3-carbonaldehyde and it is one of the parts in the structure of acrylamide. Therefore, acrolein can be known as a precursor as a formation of acrylamide. Transformation of lipids: when the oils or fats are being heated at a temperature above the smoke point, the glycerol will naturally degrade into at the same time, there is unpleasant acrid black and irritating smoke formed during the process. More unsaturated oil, the more acrolein is formed and hence this leads to a lowering smoke point. This is because high smoke points of oil contain more saturated fatty acid and low polyunsaturated acids. During oil heating process, the smoke will appear on the surface of heated oils before their temperature reaches 175 degrees Celsius. While oil heating, the oils were then hydrolyzed into glycerol and fatty. At the same moment, acrolein is formed, through the process of eliminating of the water from glycerol, by a hydrolytic acid, catalyzed carbonium mechanism. Based on the hydrolytic acid, catalyzed carbonium mechanism, we know that acrolein is formed from the acylglycerol. Besides, acrolein can also be a product that forms from the oxidation of polyunsaturated fatty acids and degradation. During lipid oxidation, carbonyl compounds are derived from lipid oxidation and work in the formation of acrylamide. This process must be carried with thermal treatment and a formulated fat-rich model system. The lipids will become the main sources of carbonyls to enhance a more evident effect in the sugar-free system. In conclusion, acrylamide can be formed from Maillard reaction, tobacco smoke, and lipid numerous strategies such as reducing heating time and temperature, pH modification, using raw materials with fewer precursors, and process technology interventions, are able to inhibit the formation of acrylamide in food system. Thank you for watching this video. Hope you have a grasp of formation of acrylamide from this insightful video.